Hello, all. Welcome to the subject of microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvati Bai, at Mamuju College of Engineering, Paguli, Pune. In yesterday's class, we have discussed about what is the stepper motor, how it will be work, and these are the tables that each step of each step depend upon the angle they have. Each step is given in the table, and also so according to that, we have to write assembly language program for particular rotation of the motor. So let's see few examples. So let's see few examples. We have to draw the 805 in connection to the stepper motor and code the program to continuously rotate it. So we have to draw a assembly language program to interface the 8051 with 8051 with the motor and continuously rotate it. So this is the task we have to do. So we have to write the assembly language program to interface 8051 with a motor, and we have to make to rotate this motor continuously. So let's write first. Let's see how to connect it or how to interface the motor to the 8051. Here the figure shows in a slide which is having 8051 connection to the stepper motor, and there are four leads for starter winding are controlled by port 1, the bits P10 to P13. The 8051 does not have sufficient current to draw the stepper motor windings. Hence, a driver like a ULN003 is required to energize the starter. So here, see there are four windings in a stepper motor. Those are connected to the port 1 pins P10 to P13, and these microcontroller is not sufficient to draw or it makes a run or rotate this motor. So that's why what will happen here, the external supply is connected to this motor. So this is the about uh, interfacing with the motor to 8051. Now let's see how to write a program to make run the motor continuously. First we have to write a command move a comma hash 6060 h. This is the hex value 66h. What it will do, it will load the step sequence. So accordingly, we have to give any value for steps, but there is some calculation also there. How? So for what rotation, what steps should be required? We have explained in a previous table. We have seen in here this table. There are at certain angle they have mentioned certain what steps. So we can consider one of these, or by altering few value the certain angle will be changed. So here they have mentioned 500 steps per revolution at 0.72 and 200.8 angle, and 180 steps per revolution at 2 step angle. So they have given like that. So let's see what happened while considering this one. Okay. P1 comma accumulator. Here what we have did here just we are loading the immediate value, the 6060 hex value into accumulator. So these are the step sequence which we have provided to this accumulator, and that value is loaded into port 1 because the 4 winding of the motor is where it was interfaced. It was interfaced to port 1 to port 1.0 to port 1.3. The next RRA, it means that rotate right clockwise. Then after we call delay, we have to call a delay subroutine. Then after that we have to jump to L1. Then we can call delay move R2 comma hash 100. Let me write first, after I will explain it. So this is the program. So what we have to do, we have to load some immediate value into the accumulator, and after that, that value loaded to the port 1 by using the accumulator. Then we have to rotate the accumulator, rotate right what the data present in the accumulator. So that will takes rotate, and after that we have to call the delay for certain amount. So I'll call delay. After that we have to short jump to L1. Where is the L1? L1 here again. So what is the delay? This is the delay. So here we call delay. So at what amount of delay it will produce? This is the delay program for the delay. Here what we have did here, moving the register R2 by the immediate value 100, and after that what will happen? It will again moving the R3 value by 255. We are loading the sum value into register 2 and register 3. Then after that what we are doing here decrement jump non-zero, whatever the value present in a R3 up to 0. It will decrement by one and start. It will decrement and jump. It will decrement whatever the value present in a R3. After decrementing, it will jump to L2. Up to what value? Till the R3, the value present in the register R3 becomes 0. So it will proceed same operation. It will first decrement, then it will become 5, 2, 5, 4. Then this is not 0 value, then it will going to jump L2. L2 where it will come again. Here we are just creating a delay. Then after it will again decrement, then it will become like this. Then it will check, is this value is 0? No, it's not 0. Then go to jump again to loop 2. So similarly, it will proceed the same operation till what? Till the value present in a R3 will become 0. So after that, what will happen? After that, once the R3 value becomes 0, then it will start to execute next instruction. What is the next instruction? It decrement jump non-zero the value present in R2 until 0. Otherwise, these two are not 0, then it will go to again L3, L3. So after seeing this same operation will be proceed here until the R2 value becomes 0 and it will go to where? Here. Then where it will become? It will become R3. So this creates a delay. This repeats the same operation to create the delay. So after that both the value become 0, then it will going to execute RET return instruction. So return instruction is nothing but exit from this loop. Then exit from this loop. Then it will become return again. Here it will start short jump to L2. So we are rotating the motor right. How we are moving? We rotate the motor at the right here. So we have to make to rotate right this motor by using this instruction rotate right whatever the value present in the accumulator. So these are the step sequence we have given. At that particular some particular angle the motor will start to rotate. So this is the simple program. So let's see further. So let's see interfacing the unipolar stepper motor using transistor. Unipolar stepper motor using transistor. So here this figure shows the interfacing of unipolar stepper motor and it will use transistors. Here the diodes are used to produce the back of EMF spike created when the coil are energized and de-energized in the same manner as the electromechanical relay. So how the electromechanical relay will be operates? So these diodes are used to reduce the spike which is produced by the coils, which is the spike will be produced by the coil whenever the coil will be, whenever coil will get energized and de-energized. So reducing that spike, the diodes are used, and tip 120 Darlington transistors can be used to supply higher current to the motor. So these are the transistors. These transistors are used to provide a high supply to the stepper motors. And the opto isolators are widely used to isolate the stepper motor EMF voltage and keep it from the damaging the controller system. So this is the configuration. Here what will happen? Here the unipolar stepper motor are interfaced to the 8051 microcontroller using this configuration. So in this configuration, what it have? It is having the diodes. These diodes are used to reduce the spike which is generated by the coil when this coil is energized and de-energized. So reducing that spikes, these diodes are used, and these transistors are used for operate or make a run to this stepper motor, because this 8051 is not sufficient to provide that much of amount of the power to make it run properly. So here few Darlington transistors are interconnected in between these two, port 1 and stepper motor, to provide a high power to the this unipolar stepper motor, and it will run fast. So this is the configuration. How it is configured we have seen already. So let's see some of the examples how we can write the program. So write a assembly language program to rotate the motor 117 degree 117 degree in clockwise direction. In clockwise direction. And the motor has a step angle of 1. The motor should having a step angle of 1.8 degree. So it means that the one step should be include 1.8 degree of the rotation. Degree of the rotation, and how many steps should be required for 117 degree of the rotation. So we have to identify first what amount of steps we have to provide to our port 1 pins to make the motor should be rotate in a this 117 degree rotational, and it should be rotated in a clockwise. Here they have given the one step angle that is equal to each step. If we provided each step, it will start to rotate at 1.8 degree rotational speed. So we have to calculate how many steps are required. How many steps are required here? So for one step, this amount of angle here they have given. We have, and they have given 117 degree of the rotation. This motor should be rotated in a clockwise direction. So we have to identify step. How many steps we have to provide to port 1 pins. We have to identify this one. So how we can identify? We can simply identify we require X. So X is nothing but 117 divided by 1.8. So just we want to have to do cross multiplication here. 117 divided by 1.8. So we have to require nearly 65. How much? 65 steps. 65 steps are required to run the motor in this degree of the rotation. So we got x value is equal to 60. These are the 65 steps. So second condition is we have to make the motor to rotate in a what direction? In a clockwise direction. So what we have to do to rotate the motor in a clockwise direction? So first we have to convert this 65 value in a Boolean form. Let's see what will happen. Here 6 is nothing but 1, 0, 1, 0. 6.